Unit conversion problems fall into one of three categories. Typically, we can convert units within either one of these standard systems, within the US customary system or within metric, or we can make conversions between the two. So in this video, let's do some examples of each of these three types of problems. Example 2 from your reading shows how to do a conversion within the US customary system. In this one, we wanted to compare two different types of basil, containers that were priced at $2.99 for 2/3 of an ounce, and basil that's sold in bunches for $12 per pound. So here we're still dealing with the US units. We've got ounces and pounds, and we're looking for a price comparison here. But what we need to do is put these on a level playing field by converting either both of these to ounces or both of these to pounds. All right, so your textbook has chosen to convert to a price per pound, and so you'll notice what we need to do is take $2.99 for 2/3 of an ounce and then multiply by that conversion factor of 16 ounces to 1 pound. So one thing that I thought was not obvious here was how we go about actually just making that calculation, right? How do you divide by a fraction? So I just wanted to point this out as a review if you don't remember this, right? So if you want to divide $2.99 by 2/3, right, you can take $2.99 and multiply by 3/2. So remember, dividing by a fraction is the same as multiplying by the reciprocal. And then this one goes on and actually adds in the conversion factor, and we're going to multiply by 16 ounces to 1 pound. All right, so we've taken care of the units up here, so this calculation is just showing the numbers, right? And then an easy way to do this would be to cancel if you can, right? So 16 and 2, we can divide both of those by 2. All right, and then this calculation just becomes $2.99 times 3 times 8. And that's where we're getting this 71.76. Another option for you is to use your calculator and to divide $2.99 by 2/3. So to do that, you just need to know that the 2/3 needs to be put in parentheses. So if you wanted to enter this on your calculator, you would do $2.99 divided by parentheses 2 divided by 3. And you can use division to indicate a fraction there. And then you can go on and multiply by 16. Now let's talk about converting with the metric system. This is the table from your reading, and one thing that I don't quite like about this is that I wish that it had put things in order either from smallest to largest or largest to smallest. Right? So what you need to do is pay attention to these values here to kind of see which one is the very largest. Right? So the very largest prefix here is tera, which means a trillion, right, or 10 to the 12th, and then it kind of backs up from there. So tera is the largest, then giga, then mega, kilo, hecto, deca, right? And then we, as we're getting smaller here, we've got to switch over to the small values on the left, right? So we would have, these are prefixes, so in between these small and large value prefixes, you would have whatever the base unit is. So if we were doing grams per se, okay, well then we would have teragrams is the largest, okay, down to decagrams, which is smaller. And then grams would be right in between decagrams and decigrams. Right? So deca means 10 grams, deci means 1/10 of a gram. So we almost have to sort of wrap around and start our prefixes over this way. Okay, so we would have grams in the middle. And then decigrams is smaller than grams, down to centi, milli, micro, nano, and pico. Okay? Right, or just reverse that if you want to go from smallest to largest. There are some different ways to remember these units. One of them is to just look at the middle 6 here. And that would be kilo, hecto, deca. Okay, and then the base units in the middle, so maybe grams or something, and then deci, centi, and milli. right? And if you look at the prefixes, this would be kilo, hecto, deca, all right, and then like your base unit with no prefix, and then deci, centi, milli. And there are some different acronyms for how to remember this. The one that I'm familiar with is King Henry died by drinking chocolate milk, and that's a way to remember it. There is also a song. I will sing it for you even though it's a little bit embarrassing, but this is a way to remember all the ones from, let's see, starting with giga and then stopping at nano. Okay, so bear with me. I'm not a music major, but here's the song. It's to the tune of This Old Man. And it goes, giga's big, mega 2, kilo, hecto, deca, through, deci, centi, milli are small, micro, nano, and that's all. All right, so the through is indicating the sort of the base unit in the middle there. Okay. So kilo, mega, kilo, hecto, deca, through, deci, centi, milli are small, micro, nano, and that's all. But of course that's not all. We have units that are smaller than this, and we have units that are larger than giga. So it's not a complete memory tool here, but it's just a way to remember some of the more commonly used ones. Okay, another helpful thing to know is how to just move your decimal point if you're going up and down this chart. So there's something called the Joule rule, and again it's another acronym to remember how to move the decimal place. Okay, so here's an example. Let's say you have, well, let's start out what this stands for. Okay, as you go down in size with the prefixes, you move your decimal point to the right, and as you go up in size, you move your decimal point to the left. So here's an example. Let's say we want to convert 2,759 centimeters to meters. Okay, so I want to know 2,759 centimeters equals how many meters? All right, well, I would use that Joule rule, and I would look for centimeters and meters. So here's centimeters, and then meters is the base unit, so that's right in between these small and large values. All right, so to go from centimeters to meters, I'm moving up to a larger unit. Okay, so that means I need to move the decimal point to the left. All right, and then how many places is determined by this exponent on the 10. Okay, so if you look at deci, which is 1/10, that's 10 to the negative first power. Right? And then deca is 10 to the first power, so you can maybe see why meters, or whatever's in the middle there, would be 10 to the 0th power. Right? So remember, 10 to the 0th is just 1, so that's why the base unit there, we're not multiplying it by anything other than 1. Okay, so we'd have like 1 meter in the middle, and then a decimeter would be 1/10 of that, a decameter would be 10 times that. Okay. So back to how many decimal places to move. What we're trying to do is move from 10 to the negative 2 to 10 to the 0th, right? So that's 2 places. So to make this conversion, all I have to do is move the decimal point 2 places to the left, right? And then this would be 27.59 meters. So for comparison, we can also find that a different way by using the conversion factor. All right, so we could start with 2,759 centimeters, and then to get to meters, I need to multiply by the conversion factor from centimeters to meters. Okay, so this chart is telling us that a centimeter is 1/100th, or 10 to the negative 2, of a meter. Okay, so 1 centimeter is 10 to the negative 2 meters. Okay, and then you can do the same thing, multiply 2,759 by 10 to the negative 2, and you could do this using a calculator or by multiplying by 1/100th, and essentially what that's going to do when you multiply by 100th, you're going to be dividing by 100, which moves the decimal 2 places to the left. Okay, so that gives you two different options, and you can take your pick which one you like better. I suspect it may be just what you're familiar with, so if you've learned the rules for moving the decimal point, perhaps you prefer that, or perhaps it makes sense to you to remember some of these conversion factors. Okay, we'll do one more example. How many nanoseconds are in a microsecond? So the how many nanoseconds, that's what we're trying to find, and we're starting with a microsecond. Right, so we want to know what is 1 microsecond, okay, and that equals how many nanoseconds. Okay, so which one is smaller, which one's larger? So we're going from micro to nano, so we're moving down to a smaller unit. So DRUL, we're moving down to a smaller unit, so we'll move the decimal point to the right. Right, and how many places? Well, we're moving from 10 to the -6th to 10 to the -9th. Right, so that's moving 3 different places. So it's kind of just the difference between -6 and -9. Okay, so you would take 1 microsecond and move the decimal 3 places to the right. All right, so a microsecond is 1,000 nanoseconds. Okay, let's talk about conversions from US customary to metric. All right, so in your textbook reading, there's an example of converting 26.2 miles to kilometers, and there is an exact conversion factor that goes from miles to kilometers, but I just wanted to show you one other way that you could do this. There's one that I always have memorized, which is inches to centimeters. Right, so I know that 1 inch equals 2.54 centimeters. Right, and as long as you have one conversion that goes from US to metric, then that's good enough for any of these situations. So it's not directly the miles to kilometers one, so this will be a longer way to do it, but it's kind of convenient if you don't have the conversion chart on hand, but maybe you know one of these factors and then you have a calculator handy. All right, so here's how you might do this. I would start with what we know, 26.2 miles, and then let's work our way down to inches, and then we can go from inches to centimeters, and then centimeters to kilometers. All right, so a lot of people know that 1 mile is 5,280 feet. All right, if you don't have that memorized, then this method probably isn't that helpful, and you would probably need to look at a chart anyway to find the conversion factor from miles to kilometers. Okay, and then we can go from feet to inches, so 1 foot is 12 inches. And now I'm ready to go from US customary to metric, so we can go from 1 inch to 2.54 centimeters. And then I need to know how many centimeters are in a kilometer. So from the metric chart, right, or again, if you have the song memorized or the acronym, okay, you could probably do this in your head, but we have 1 kilometer, and we want to know how many centimeters that is. Okay, so I'm going from kilo, which is 1,000, okay, down to centimeters, which is 100th. All right, so looking at the exponents, I'm going from 10 to the third to 10 to the -2. Okay, so 10 to the third down to 10 to the 0th is 3 decimal places, and then 10 to the 0th down to -2 is another 2, all right, or just the difference between 3 and -2 is 5 places. All right, so I'm going to move the decimal point 5 places, and then left or right, well, we're going down this chart, we're going down to a smaller unit, so we're going to move it right 5 places. Okay, so a kilometer is 1,000 centimeters. I'm sorry, 100,000 centimeters. Okay, so I can add in that conversion factor. 100,000 centimeters is 1 kilometer. So you can see that all of the units are taken care of. Miles cancel, feet cancel, inches cancel, and centimeters cancel, and we're left with kilometers. And then if you do all of this multiplication, 26.2 times 5280 times 12 times 2.54, and then divide by 100,000, you'll end up with 42.1 0.1648, etc., dot, 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 kilometers, okay? And if we wanted to round to the tenths place, that would be about 42.2 kilometers. Okay, so you do get the same answer if you do it this way versus going straight from miles to kilometers. Okay, what about square kilometers to square miles? Right, so the solution in your textbook uses a rule of equations, which is that you can do the same thing to both sides of the equation and you still end up with a true equation. Right, so if you know the conversion from miles to kilometers, okay, a mile is 1.6093 kilometers. Right, then to get to square miles and square kilometers, we're just squaring both sides. Okay, and that's a rule from algebra, you're allowed to do that. Another option would be to just use the conversion factors a few times, like we did in the last unit. Right, so we want to know how many square kilometers in 1 square mile. So start with a mile squared. Okay, and then that just means 1 mile times mile. And then to go to kilometers squared, right, we need to multiply by the miles to kilometers conversion factor twice. Okay, so we'd have 1 mile is 1.6093 kilometers, and do that twice. Okay, so you can see what we're multiplying by is just 1.6093 twice, or squared. All right, so that's why it's the same thing. This works with cubic units too, so if you wanted to go from miles cubed to kilometers cubed, you would just cube both sides of the equation. You could go from inches cubed to meters cubed, or anything like that. And for our last example in this video, let's talk about temperature conversions. So in your reading, you had this figure that shows you the different scales, Fahrenheit, Celsius, and Kelvin, and your book had some notes on where we get this equation. So the conversion equation from Celsius to Fahrenheit is just that Fahrenheit equals 1.8 Celsius plus 32. Okay, so here's the observation. 100 degrees on the Celsius scale, right, is the same thing as 180 degrees on the Fahrenheit scale. All right, because that's just the difference between the temperatures at which water freezes and which water boils. So we're talking about the same temperature, we're just labeling it differently, right? But it's still, an absolute distance between those two. Okay, so what we're saying with this 1.8, right, is that for every 180 degrees on the Fahrenheit scale, that's equivalent to 100 degrees on the Celsius scale. Right, so if you just divide those, 180 divided by 100, that's where you get this 1.8. In addition to that, we just have this 32, which represents a different starting point. Right, so rather than starting at 0 on the Celsius scale, Fahrenheit starts at 32 and then goes up 1.8 degrees for every 1 degree that Celsius goes up. Right, so this plus 32 is indicating the shifted starting point. Now Kelvin and Celsius are the same except for the starting point. So Kelvin is just Celsius plus 273.15. Okay, or in other words, if you look at 100 degrees on the Celsius scale, that's equivalent to 100 degrees on the Kelvin scale. Right? So the only difference here is just that starting point. So we don't need to multiply Celsius by anything, but we just need to add or shift it by 273.15. Okay, so this concludes the examples for this video. We've done some converting just within US customary, converting within metric, and then converting back and forth between the two with different units, temperature, weight, volume, things like that. In the next video, we will talk about some specific units in context. So you'll see units used to describe energy and power, and density and concentration in real life examples. So we'll talk through some of those.